Polynomial functions is Unit 6 of the course Applied Algebra or APA. Objective number 1, define and graph quadratic function. So this is the definition of quadratic function. It is a polynomial function of degree 2, meaning to say the highest exponent is 2. So this is the general form of the quadratic function. F of x equals ax squared plus bx plus c, where a is not equal to 0. Why a is not equal to 0? Because if this a here is 0, there will be no quadratic term. And this is the standard form of the quadratic function. It's f of x equals a times the quantity x minus h squared plus k, where h, k is the vertex. Now we are going to graph a quadratic function. Example number 1. Graph f of x equals x squared minus 4. This equation is in the form f of x equals ax squared plus bx plus c. Now the graph of a quadratic function is called a parabola. It is a U-shaped graph. First, we are going to find the vertex or the turning point of the graph. So the graph has coordinates x and k. To find h, this is our formula. It's negative b over 2 times a. Our b here is 0 because b is the coefficient of the linear term, and we don't have linear term here, so that's 0. While our a here is 1. That's the coefficient of the quadratic term. So that means negative 0 over 2 times 1, that is equal to 0. And our k has the formula f of h, meaning to say whatever we obtain for h, we are going to substitute that into x. So this means we have 0 squared minus 4, which is equal to negative 4. So our vertex has coordinates 0, negative 4. And now our sign of a. A again is the coefficient of x squared. So the coefficient of x squared here is 1, so the sign is positive. Why is it important to know the sign of a? Because if a is positive, the opening of our U-shaped graph is upward. On the other hand, if it is negative, the opening is downward. Now let's find the y-intercept. So y-intercept is the value of y when x is 0. Now if we are going to substitute 0 here into our x, we have 0 squared minus 4. And this gives us negative 4. So the y-intercept is negative 4. How about the x-intercepts? The x-intercepts are the values of x when y is 0. So this f of x is actually y. So we are going to change this to 0 and solve for x. So we have x squared minus 4 equals 0. X squared minus 4 is factorable, and the factors are x plus 2 and x minus 2. Equating both factors to 0, we have x plus 2 equals 0 and x minus 2 equals 0. On our first equation, x equals negative 2. So on our second equation, we have here x equals 2. So the x-intercepts are negative 2 and 2. Our line of symmetry has the equation x equals h. So this is the h here. So that means x equals 0. And the domain for our U-shaped graph, it's always set of all real numbers. And for our range, if our a is positive, so it's settable numbers y such that y is greater than or equal to k, and it's settable real numbers y such that y is less than or equal to k if a is negative. Our a here is positive, so that means our range is settable real numbers y such that y is greater than or equal to -4. Now we are going to graph f of x equals x squared minus 4 using the important information we get here. So this is our vertex, 0, -4, and these are our x-intercepts, -2 and 2. Then we connect these 3 points with a smooth curve or a U-shaped graph. This is the graph of our equation. Now how about this line of symmetry? It's x equals 0. So this is a line that divides our U-shaped graph into 2 congruent parts. Notice here that if we are going to fold our graph along this line, the 2 parts coincide. Example number 2. Graph f of x equals -x squared plus 6x minus 5. So the graph of this function is a U-shaped graph called parabola. So the vertex has coordinates h, k. H has the formula -b over 2a. Our b here is 6 and our a is -1. So we have -6 over 2 times -1, and that gives us 3. And for our k, it's f of h, meaning to say whatever we obtain for h, we are going to substitute that into all the x's we have in our function. So that means that's negative of quantity 3 squared plus 6 times 3 minus 5. And if we are going to simplify this, this gives us 4. So that means the vertex has coordinates 3 and 4. How about the sign of our a? So a is the coefficient of the quadratic term, so it's -1, so it's negative. So because the sign of a is negative, the opening of our U-shaped graph is downward. Now let's find the y-intercept. The y-intercept is the value of y when x is 0. So meaning to say, we are going to substitute 0 into all the x's we have here. So that is negative of 0 squared plus 6 times 0 minus 5. Simplifying this, we have -5. So our y-intercept is -5. Now how about the x-intercepts? X-intercepts are the values of x when y is 0. So meaning to say, we are going to change this f of x to 0 and solve for x. So we have -x squared plus 6x minus 5 equals 0. So this quadratic trinomial is factorable, and the factors are the quantity x minus 1 times the quantity -x plus 5. Equating both factors to 0, we have x minus 1 equals 0 and -x plus 5 equals 0. And solving the first equation, we have x equals 1. And solving the second equation, we have x equals 5. So the x-intercepts are 1 and 5. How about our line of symmetry? Our line of symmetry has the equation x equals h. So h here is 3, so that means it's x equals 3. Again, the domain of our U-shaped graph or parabola is settable real numbers. How about the range? So our a here is negative, so that means our range is settable real numbers y such that y is less than or equal to k, which is 4. Now let's graph our function. So this is our vertex, and our graph opens downward. Our y-intercept is -5. Our x-intercepts are 1 and 5. Connecting these 4 points with a smooth curve whose vertex is here, we have this U-shaped graph. How about the line of symmetry? The line of symmetry has the equation x equals 3, so this is the line. This is the line that divides our graph into two congruent parts. Again, if we are going to fold our graph along this line, the two parts coincide. Objective number 2. Express a quadratic function from general form to standard form. So this is our standard form. Example number 3. Express f of x equals x squared plus 4x minus 1 in standard form. So this is how we are going to do it. First, we are going to enclose in parentheses the terms with variable x. So we have the quantity x squared plus 4x, then outside the parentheses minus 1, the constant. Why do we have a space here? Because we are going to complete the square inside the parentheses. To complete the square, we are going to find half of the numerical coefficient of the second term. So it's 4. Half of 4 is 2. Then square it, meaning to say 2 times 2, that's 4. So we add 4. And because we added 4 inside the parentheses, we are going to subtract 4 outside the parentheses to compensate. So, because this is already a perfect square trinomial, it can be written as the quantity x plus 2 squared. And outside the parentheses, minus 1 minus 4 is minus 5. So this is now the standard form. Example number 4. Express f of x equals negative x squared plus 12x plus 7 in standard form. Again, we are going to enclose in parentheses the terms with x. So we have negative x squared plus 12x inside the parentheses, then the constant outside, that's minus 7. Notice here that we have a negative sign before x squared. We are going to move this negative sign outside the parentheses, so it becomes negative 1 times the quantity x squared minus 12x. Notice here that positive 12x becomes minus 12x. Now we are going to complete the square inside the parentheses. So 1/2 of 12 is 6, then 6 times 6 is 36. So we are going to add 36 here, and then we are going to add 36. Why not subtract 36? It's because we have a negative 1 outside the parentheses here. If we multiply back, that's negative 1 times x squared, that's negative x squared. And then negative 1 times negative 12x, that's positive 12x. Negative 1 times positive 36, that's negative 36. So that means we added a negative 36 inside the parentheses, so we are going to add 36 outside the parentheses. We have a negative number outside, negative 1, so we can just write negative. And then to express this as square of a binomial, we have the quantity x minus 6 squared. And then outside the parentheses, we have negative 7 plus 36, that's positive 29. So this is the standard form. Objective number 3. Determine the vertex of a parabola which opens upward or downward and its x-intercepts. Example number 5. Determine the vertex of the parabola f of x equals the quantity x plus 6 squared plus 4. Our equation is already in standard form. Our vertex here is hk. So therefore, our vertex here is negative 6, positive 4. So notice here that if we have plus 6, our x-coordinate is negative 6. And outside the parentheses, it's plus 4, it's still positive 4. Example number 6. Determine the vertex of the parabola f of x equals 2 times the quantity x minus 5 squared minus 7. Again, this equation is written in standard form. So this means the vertex of this parabola has coordinates 5 and negative 7. Example number 7. Determine the vertex of the parabola f of x equals h squared plus 6x plus 5. So our equation is written in general form. To find the vertex hk, we are going to solve for h and then solve for k. So for our h, this is our formula. H equals negative b over 2a. So our b here is 6, our a is 1, so that's h equals negative 6 over 2 times 1, which gives us negative 3. To find k, we are going to find f of h. That means whatever we find for h, we are going to substitute that into the excess we have in our function. So that means we have negative 3 squared plus 6 times negative 3 plus 5. Then simplifying this, we have negative 4. So that means our vertex has coordinates negative 3, negative 4. Example 7.1. Determine the x-intercepts of the parabola f of x equals x squared plus 6x plus 5. So here, we are going to solve the equation. So we have x squared plus 6x plus 5 equals 0. Then, we are going to factor the trinomial. So the factors of x squared plus 6x plus 5 are the quantity x plus 1 times the quantity x plus 5. So we have equals 0. Equating both factors to 0, we have x plus 1 equals 0 and x plus 5 equals 0. Solving for x on our first equation, we have x equals negative 1. And solving for x on our second equation, we have x equals negative 5. So the x-intercepts are negative 1 and negative 5. Example number 8. Determine the vertex of the parabola f of x equals negative x squared plus 8x minus 1. So first we are going to find h. The formula is negative b over 2a. Our b here is 8 and our a is negative 1. So we have h equals negative 8 over 2 times negative 1. And negative 8 divided by 2 times negative 1 equals 4. And to find k, we are going to find f of h. So meaning to say, whatever we obtain for h, we are going to substitute that into all the excess we have in our function. So that's negative of 4 squared plus 8 times 4 minus 1. And simplifying this, it gives us 15. So the vertex has coordinates 4 and 15. Objective number 4. Solve applied problems involving the minimum and maximum values of a quadratic function. Example number 9. Abdulaziz Furniture has a daily cost production given by C equals 3,000 minus 40x plus x squared, where C is the cost in Saudi riyals and x is the number of units produced. What daily production gives the minimum cost? To answer this question, we are just going to find the x-coordinate of the vertex. And the formula is h equals negative b over 2a. Our b here is negative 40 and our a is 1. So we have h equals negative of negative 40 over 2 times 1. And this is equal to 20. So meaning to say, the daily production that gives the minimum cost is 20 units. Objective number 5. Divide polynomials by long division or synthetic division. Example number 10. Divide the quantity 3x squared plus 2x minus 4 by the quantity x minus 1. So we are going to perform a long division. So this is how we set it up. We write 3x squared plus 2x minus 4, our dividend, under the long division sign. Then we are going to write our divisor x minus 1 outside. First step, first term in our dividend divided by the first term in our divisor. That's 3x squared divided by x. That's 3x. Then multiply back. 3x times x equals 3x squared. 3x times negative 1 equals negative 3x. Then we are going to subtract. 3x squared minus 3x squared is 0. Then 2x minus negative 3x, that's 5x. Then bring down the next term, that's minus 4. Then again, first term here divided by the first term in our divisor. So that's 5x divided by x. that's positive 5. Then multiply back again. 5 times x is 5x. 5 times negative 1 is negative 5. Then subtract again. So we have 5x minus 5x is 0. Negative 4 minus negative 5 is 1. So this number here is our remainder. This is how we are going to write our answer. We will write our quotient 3x plus 5. Then we are going to make a fraction where the remainder is the numerator and our divisor as the denominator. So it's plus 1 over x minus 1. So this is our answer. Example number 11. Divide the quantity 2x cubed plus 3x squared minus 2x minus 2 by the quantity x minus 1. So this time we are going to perform synthetic division. In synthetic division, we only have to write the numerical coefficients. So in this case, it's 2, 3, negative 2, negative 2. Then, for our divisor, we also have to write the constant. So if we have x minus 1, our constant here is positive 1. Okay, then the first thing we are going to do is bring this first number down. Then multiply. 1 times 2 is 2. Write the answer here. Then add. 3 plus 2 is 5. Then multiply again. 1 times 5 is 5. Write the answer here. Then add again. Negative 2 plus 5, that's 3. And then 1 times 3 is 3. Write the answer here. Then add again. So negative 2 plus 3 is 1. So what do these numbers mean? So this 2 is just the coefficient of the quadratic term. So that's 2x squared. Notice here that our degree is less than the degree of our dividend. And this 5 here is the coefficient of the linear term. So that's plus 5x. And this 3 here is our constant. And then this 1 here is our remainder. So we are going to write a fraction where this remainder is our numerator and the divisor as our denominator. So that's plus 1 over x minus 1. So this is our answer. Objective number 6. Apply the remainder theorem to determine the remainder when f of x is divided by x minus k, and the factor theorem to determine whether x minus k is a factor of f of x or not. So example number 12. What is the remainder if the polynomial p of x equals x cubed plus x squared minus 3x plus 6 is divided by the binomial x minus 3? So by remainder theorem, we are going to substitute 3 into all the x's we have in our function. So that becomes p of 3 equals 3 cubed plus 3 squared minus 3 times 3 plus 6. Then we are going to simplify this. So 3 cubed is 27, then 3 squared is 9, 3 times 3 is also 9, then plus 6. So 27 plus 9 minus 9 plus 6 equals 33. So this is the remainder when this polynomial is divided by the binomial x minus 3. Example number 13. Is x minus 2 a factor of x squared plus 3x minus 4? So by factor theorem, we are going to substitute 2 into all the x's we have in our polynomial function. So that's p of 2 equals 2 squared plus 3 times 2 minus 4. So simplifying this, 2 squared is 4, then 3 times 2 is 6, then minus 4. So 4 plus 6 minus 4 equals 6. This 6 is our remainder. So since our remainder is 6, x minus 2 is not a factor of the polynomial x squared plus 3x minus 4. But if our remainder here is 0, we can say that a binomial here is a factor of the polynomial function. So the answer is no. Objective number 7. Determine the zeros of a polynomial. Example number 14. What are the zeros of f of x equals x cubed plus 3x squared minus x minus 3? So the probable zeros we have here are the factors of negative 3. The factors of negative 3 are positive and negative 1, positive and negative 3. So we are going to try one of this. Using synthetic division, we will try 1. First, we are going to bring down the first number 1. Then multiply 1 times 1 is 1. Write the answer here. And then add. 3 plus 1 is 4. Then again multiply 1 times 4 is 4. Write the answer here. Then add again. Negative 1 plus 4 is 3. Then again multiply 1 times 3 is 3. Write the answer here. And negative 3 plus 3 is 0. So since the remainder is 0, 1 is one of the zeros. Now to find another zeros, we can solve for x here in our reduced function. This 1 means the coefficient of our quadratic term, and this 4 means the coefficient of our linear term, and then we have 3 here as the constant. Now if we are going to equate this to 0, we will be able to find the other zeros. So x squared plus 4x plus 3 equals 0. And x squared plus 4x plus 3 is factorable, and the factors are the quantity x plus 1 times the quantity x plus 3. Equating both factors to 0, we have x plus 1 equals 0 and x plus 3 equals 0. Solving for x in our first equation, we have x equals negative 1. And solving for x in our second equation, we have x equals negative 3. So this means the zeros are 1, negative 1, and negative 3. Thanks for watching, guys. This is Teacher Rejil. Keep safe.